Hello, in this video, we are going to be solving a nice exponential equation 8 raised to x minus 2 raised to x divided by 6 raised to x minus 3 raised to x equal to 2. How do we find the value of x? First, let us rewrite 8 to the power of x. We can rewrite it as 2 raised to 3 times x minus 2 raised to x divided by 6, also could be written as 2 times 3 raised to x minus 3 raised to x equal to 2. Let's continue. So we have 2, 3 times x, that is 3x minus 2 raised to x divided by 2 times 3 raised to x could be written as 2 raised to x times 3 raised to x minus 3 raised to x equal to 2. You will see that we can also write 2 raised to 3x as 2 raised to x times 2 raised to 2x minus 2 raised to x divided by 2 to the power of x times 3 raised to x minus 3 raised to x equal to 2. Now let us pull out the common terms. From this numerator, 2 to the power of x is common. If we factor it out, we have 2 raised to x into 2 raised to 2x minus 1 divided by, you will also notice that at this denominator 3 raised to x is common, so we have 3 raised to x into 2 raised to x minus 1 equal to 2. Let's continue. 2 raised to x times 2 raised to 2x can also be written as 2 to the power of x times 2 minus 1 could be written as 1 square, everything divided by 3 raised to x times 2 raised to x minus 1 equal to 2. Now let us recall this identity property, that is a square minus b square is equal to a minus b times a plus b. Take note of this property, we are going to use it later. So from this line we have 2 raised to x. If we apply this property to this guy, we are going to have 2 raised to x minus 1 times 2 raised to x plus 1 divided by 3 raised to x times 2 raised to x minus 1 equal to 2. What do you notice here? You will notice that 2 raised to x minus 1 cancel each other, so we are left with 2 raised to x times 2 raised to x plus 1 divided by 3 raised to x equal to 2. Now, let us multiply both sides by 3 raised to x so that we can get rid of this guy. So that will be 3 raised to x times 2 raised to x times 2 raised to x plus 1 equal to 2 times 3 raised to x divided by 3 raised to x. Clearly, 3 raised to x cancel each other. We are left with 2 raised to x times 2 raised to x plus 1 equal to 2 times 3 raised to x. Let us take note of this beautiful equation. We are going to test several values of x using this equation. First, let us assume that if x is equals to 1, so we have to test for when x is equals to 1 using this equation. 2 to the power of x times 2 to the power of x plus 1 equal to 2 times 3 raised to x. So when x equals to 1, this left hand side becomes 2 raised to 1 times 2 raised to 1 plus 1 equal to 2 times 3 raised to 1. 2 raised to 1 is 2 times 2 raised to 1, that is 2 plus 1 equal to 2 times 3. So we have 2 times 2 plus 1, that is simply 3, equal to 2 times 3. 2 times 3, that is simply 6, equal to 2 times 3. We have 6. This shows that the left hand side is equal to the right hand side. This also means that x equal to 1 is true for this exponential equation. That is, s equal to 1 is one of the solutions. Now, let us assume another value of x. So, let us also assume if this case is true. Assume if s is greater than or equals to 2. We have to test it using our equation, which is 2 raised to x minus 1 times 2 raised to x plus 1 equal to 3 raised to x. You will notice that in as much s is greater than or equals to 2, 2 raised to x minus 1, we always produce an even number. That is, 2 raised to x minus 1 is always even when s is greater than or equals to 2. For example, when s equals to 2, this power becomes 2 minus 1, which is 1, and 2 raised to 1 is 2, which is an even number. Also, if s is greater than or equals to 2, this side is always an odd number, but this guy, 3 raised to x, is always an odd number. For example, when s equals to 2, we have 3 square, and 3 square is 9. 9 is an odd number. When s is equals to 3, that is 3 to the power of 3, which is 27, and 27 is an odd number. So let's continue. Whenever we multiply both even and odd together, this will always produce an even number. That is, simply put, even times odd will always produce an even number, and this guy is odd, so we have odd here. And there is no way an even number will be equal to an odd number. This means that for the case when s is greater than or equals to 2, there is no solution. That is, if x is greater than or equals to 2, there is no solution. Let's also consider another case. So, assume if x is equals to minus p, such that p is greater than or equals to 1. We have to test this using the same equation. 2 raised to x minus 1 times 2 raised to x plus 1 equal to 3 raised to x. When x equals to minus p, this becomes 2 raised to minus p minus 1 times 2 raised to minus p plus 1 equal to 3 raised to minus p. We can write this guy as 2 raised to minus into p plus 1 times 2 raised to minus p plus 1 equal to 3 raised to minus p. 2 raised to minus into p plus 1 can also be written as 1 divided by 2 raised to p plus 1 times 2 raised to minus p can also be written as 1 divided by 2 raised to p plus 1 equal to, we can also rewrite 3 raised to minus p as 1 divided by 3 raised to p. So we have 1 divided by 2 raised to p plus 1 times, the LCM here is 2 raised to p, so that will be 2 raised to p over 2 raised to p divided by 2 raised to p, that is 1. 1 times 1, we have 1 plus 2 raised to p times 1, that is simply 2 raised to p, equal to 1 divided by 3 raised to p. So we have 1 times 1 plus 2 raised to p, that is 1 plus 2 raised to p divided by 2 raised to p plus 1 times 2 raised to p, that is 2 raised to 2p plus 1 equal to 1 divided by 3 raised to p. We can cross multiply here. 3 raised to p times this numerator, we have 3 raised to p times 1 plus 2 raised to p equal to 2 raised to 2p plus 1 times 1, that is simply 2 raised to 2p plus 1. And don't forget our condition for p. P is greater than or equals to 1. And when p is greater than or equals to 1, 3 raised to p is an odd number for p greater than or equals to 1. And 1 plus 2 raised to p is always odd for p greater than or equals to 1. That is when p is equals to 1, 2, 3, on and on like that. And this guy, 2 raised to 2p plus 1, we always produce an even for p greater than or equals to 1, when p is 1, when p is 2, when p is 3, on and on like that. If we multiply both odds together, odd times odd, this will always produce an odd, and this guy is even. And there is no way an odd number will be equals to an even number. Therefore, if x equals to minus p, there is no solution. There is no solution for x equals to minus p. So, as a result of all this, the only solution, the only solution that we have for this exponential problem is simply x equal to 1. This is the required value of x for this exponential problem. That's it. Thanks for watching.